Welcome to The Explainer. Grab a seat because today we are stepping into what I like to call an elite engineering masterclass. Look, if you think buying a new dishwasher in 2026 is just about whipping out a tape measure to check the dimensions of a hole in your kitchen cabinet, you need to completely reset your expectations. We have reached this crazy inflection point where artificial intelligence, advanced thermodynamics, and hyper-efficient fluid dynamics are all converging right under your kitchen counter. Buying a top-tier appliance today? It's no longer just a simple household chore. It is a high-stakes capital allocation that's going to impact your daily routine for the next 15 to 20 years. So let's get into it.
Now, I know exactly what some of you do when you walk into an appliance showroom. You stroll straight up to the machine with a control panel that looks like a literal spaceship, boasting 15 different wash cycles. And you think, yep, this is the one. Let me stop you right there. Humor me for a second. When was the last time you used absolutely anything other than auto, heavy, or quick wash? Exactly. That's why our strategic imperative here is so crucial. Excessive cycles are very often just a shiny distraction masking poor core engineering. You really don't need a dedicated crystal stemware cycle if the machine's underlying pump architecture is cheap. You need brilliant engineering, not just more buttons.
I want you to think about this number, 2.5. That is the strict sub 2.5 gallon water standard for a full, heavy wash load in 2026. Older, wasteful models used to just slosh gallons upon gallons of hot water to get the job done. Today, thanks to hyper-efficient fluid dynamics and real-time sensors, these modern machines can clean an entire dinner party's worth of dishes using less water than you probably use while brushing your teeth. I mean, it is an absolute marvel of modern engineering.
All right, here's our roadmap for this explainer. First, we'll cover the 2026 dishwasher revolution. Second, engineering the perfect wash. Third, mastering silence and drying. Fourth, global appliance design philosophies. And finally, crucial infrastructure and maintenance.
Let's kick things off with Section 1, the 2026 dishwasher revolution. Time to dismantle the myth of the simple water sprayer. When top-tier engineering consultants evaluate these modern washing platforms, they aren't looking at glossy marketing brochures. They're analyzing 5 critical pillars. First, hydrodynamic efficiency, basically getting the absolute maximum wash action with the least amount of water. Next, thermodynamic drying performance. Then, acoustic isolation, because let's face it, nobody wants a jet engine roaring in their open-concept kitchen. Fourth is volumetrics and ergonomics, essentially how well that third rack is actually integrated into the space. And finally, system diagnostics and connectivity. We're talking about machines that can predict a pump failure before a single drop of water ever hits your hardwood floor. Moving right along to Section 2, engineering the perfect wash. This is where the black magic tech really starts. So, traditional dishwashers, they relied on single-speed induction motors. And honestly, they were kind of dumb. They just sprayed water at a constant pressure, no matter what was inside. But the 2026 standard dictates the use of BLDC or brushless direct current inverter motors. These systems are paired with incredible optical turbidity sensors that actually shoot beams of light through the wash water to check its clarity thousands of times a second. If the algorithm senses heavy, baked-on proteins, it dynamically cranks up the pump RPM, boosting water pressure to the lower spray arms to just blast it away. But if the water is relatively clear, it drops the pressure, conserving energy and gently babying your delicate glassware. It is quite literally washing with a brain. Okay, Section 3, mastering silence and drying. Let's talk about the thermodynamics and acoustic warfare happening inside that stainless steel tub. Historically, drying wet plastics has been a total nightmare, right? Plastic has incredibly low thermal mass, so it just doesn't hold on to heat. Well, enter zeolite. I like to playfully describe zeolite as magic sweat-absorbing rocks that spit out fire. It's actually an aluminous silicate mineral with a highly porous crystalline structure. During the drying phase, a fan pulls damp air from the tub into a sealed chamber full of these zeolite beads. They absorb the moisture and undergo a massive exothermic reaction, releasing dry heat that often exceeds 176 degrees Fahrenheit. That incredibly hot, dry air is pumped right back into the tub, finally solving the wet Tupperware problem without relying on energy-hogging exposed heating coils. And the best part? The minerals naturally recharge themselves during the next hot wash cycle. It's a permanent, closed-loop thermodynamic masterpiece. But dealing with the heat is only half the battle. Dealing with the noise is acoustic warfare. To drop noise levels below 38 A-weighted decibels, engineers have to engage in extreme multi-layer acoustic dampening. At those sub-40 decibel levels, the real enemy isn't the motor humming anymore. It's the actual sound of water droplets striking the steel tub.
To combat this, they bake a thick layer of asphalt-like bitumen directly onto the outside of the stainless steel to completely kill the resonance. Over that, they wrap a super dense blanket of cotton or recycled denim. Finally, the entire base pan is sealed completely shut to trap those low-frequency hums. The result? Absolute kitchen serenity.
Which brilliantly brings us to Section 4, Global Appliance Design Philosophies. A real global showdown. You see, the global market operates on this deeply segmented insider matrix. We essentially have European finesse, American brute force, and Asian tech integration. Each region tackles the age-old problem of dirty dishes with a completely different set of priorities. Understanding this matrix is the absolute key to matching a machine to your specific household lifestyle. Let's heavily contrast the Europeans and the Americans for a second. European brands like Miele and Bosch prioritize absolute finesse. They are aiming for 20-year longevity, whisper-quiet operation, condensation drying, often utilizing that zeolite we just talked about, and the total preservation of your dishes. They don't use exposed heating elements, period. On the flip side, we have the American legacy, your KitchenAids and GEs. This is pure brute force. They favor massive volumetric capacity, think third racks deep enough for actual mugs and cereal bowls, heavy soil removal, and they absolutely aren't afraid to use a traditional heated dry cycle with a glowing exposed element to just bake the water right off. And then, right in the mix, we have the Asian market. Dominated by brands like LG and Samsung, they bring a massive tech-savvy edge to the kitchen. LG utilizes true steam technology, literally injecting pure steam into the tub to melt away stubborn starches before the mechanical scrubbing even begins. Samsung uses pressurized water wall technology, replacing the traditional spinning arm with a gliding bar that creates a literal wall of pressurized water. It's incredible innovation. But all of this black magic tech brings us to the harsh reality of what happens when you actually install it in your home. Finally, we hit Section 5, Crucial Infrastructure and Maintenance. Because even the most advanced machine will die a premature death if your kitchen's infrastructure is hostile. Let's talk about the 7 grains per gallon rule. Listen closely. If your local water supply exceeds 7 grains per gallon of hardness, you have hard water. That hardness is essentially calcium, and it will build up and literally clog the internal arteries of your appliance. If you have hard water, you must, and I mean absolutely must, buy a machine with a built-in water softener. These systems use specialized salt to regenerate an internal ion exchange resin, protecting your heating elements from calcification and keeping your glassware from looking perpetually cloudy. Which brings me to my rigorous and perhaps slightly snobby lecture on appliance hygiene. The myth of the maintenance-free dishwasher? It is dead. If you want 15 to 20 years out of your investment, you need filter discipline. Because modern machines are so whisper quiet, they use passive microfilters instead of those loud, old-school food grinders. You have to pull that filter out and manually rinse it under hot water every 2 weeks. If it clogs, the pump starves for water, leading to cavitation and terrible wash performance. You also need to run a high-quality descaling agent every 6 months to clear hidden grease. And finally, you absolutely must respect the chemistry of your detergent. Seriously, stop buying cheap, bulk liquid gels. Because these 2026 machines are sipping a microscopic 2.5 gallons of water, pouring in massive glugs of excessive, cheap detergent is a total disaster. It creates a mountain of suds inside the tub. The optical and pressure sensors interpret those thick, foamy suds as water volume, which completely tricks the machine's brain, leading to severe pump malfunction and very expensive leaks. You need high-quality, perfectly dosed enzymatic pods or powders. Nothing else. So, as we wrap up this masterclass, I want to leave you with one final, provocative question. Are you ready to respect the chemistry? Now that you know all about turbidity sensors, zeolite thermal storage, acoustic bitumen layering, and the 7 grains per gallon rule, you can no longer plead ignorance. You are now fully empowered to look right past the superficial marketing, analyze the core engineering metrics, and make a highly strategic, long-lasting capital allocation for your kitchen. Thanks for joining me on this explainer, and I'll catch you next time.